Hello everyone, this is our Big Data course project demo, and our project is named Hybrid Movie Recommender. I am Yizhou Wang, and I'm going to firstly introduce the datasets we used in the project, and then I will introduce a simple code demo and its results. And after that, Xingyuan will put the recommendation results in System G, then discuss and evaluate our results. So let's go to the first part. The first part, I will introduce the datasets we use in the project. In this project, we used two movie reviews datasets. First one is Yahoo Movie Lab, and the second one is Amazon Movie Reviews. Now I will show you what information this dataset contains. First one is Yahoo Movie dataset. There are 6 test views in this dataset. The first one is user movie ratings train, and second one is user movie rating test. These two tests is containing user ID, movie ID, and ratings. So their ratings mapping from users to movies. And the third dataset is user demographics. This contains users' information, including user ID, its birth year, and gender. The fourth dataset is movie content description. There are so many movie content in this dataset, and it's in this kind of format. And the fifth one is movie mapping to movie length. This is the map from Yahoo Movie to movie length dataset. It's including movies names. And the last one is mapping to each movie. This actually the similar as the former one. About the second dataset, the Amazon movie reviews. There are several reviews content in this dataset. The user ID, the profile name, the helpfulness, score, time, summary, and test. There are total about 8 million reviews. So we actually use just part of it because it's so large. And let's go to the second part. In the second part, I'm going to show how the coding run and how the results like. So you can see we firstly build a Maven project in the Eclipse and build a recommendation system. This is our project, and you can see there are 4 data fields, actually just three kind of them. The first one is data. This data is just from the user movie training test, and the second one is demographics. This actually from the user demographics text, and the third one is synopsis. It means the movie content description. So we can run this code, and we can come to the main function. In the main function, we can see there are 3 models. The first one is demographic model, the second one is synopsis model, and the third one is failed model. The first model just means the user-based model in our project report, and the second synopsis model is means the content-based model, and the third model is actually built from our data. So in the recommend for all users function, there are totally 100 for loops. So it will it means the task number of users. For example, if you want to test the full data set, you can replace this as a full number of data set users of data set. And here we just a demo, so we change the number to 100. So it will just run the first 100 users just like this. It will stop at the 100. For each recommendation for each user, it will find a user's neighborhood as a movies recommended to this user, and after that it will print out the recommendation results as a CSV file. Because this field will used for data visualization in systemg, because systemg need to load two SCV fields as nodes and edges. And you can see our recommendation results, and each user here we recommend 5 movies. This is movies ID. So let's come to the next part.
This is part 3 of our demo, and in this part, I'm going to introduce data processing and system evaluation of our project. So to analyze the result of this demo, we use systemg to visualize the data. This is the whole look of our visualization. And in this graph, movies and users are represented at points, and ratings of each movie are directed edges points to movie nodes. So you can see left part of our systemg. We assign blue to female user nodes and green to male user nodes. And here are some gender undefined users, so we present them as red nodes. And orange nodes are movies which our system recommends to specific users. And for the labels, labels of users' nodes are their ID number, and to make the graph be more visible, we show the name of each movie as labels of movie nodes. So the node size is decided by degree in display. Thus, we can highlight the most recommended movie. So let's see some specific details. In this part of the graph, we can see 3 user nodes, number 14, number 23, and number 50. Each of them are connected with 5 movie nodes. That is, our system recommends 5 movies to each user. And notice a movie named Natural Born Killer. It connects both user number 14 and user number 50. That is, our system recommends this movie to those 2 users at the same time. And because our recommendations are based on users' birth year, gender, and similarity between movies, then it is obviously that user 14 and user 50 have some characteristics in common. This analysis has already been shown in previous part and will also be shown in our report, so I will now do it again at this point. And to see some more details, I'm going to show you a most recommended movie named Tokiboki. This is the node with biggest size in the whole graph. And first, let's see some details, properties of this movie node. This movie was released in 1973 and is really popular in the following decades. The in-degree value of this node is 16. That means our system recommends it to 16 of 50 users at the same time. And to do some analysis, um, I list complete the information of all those users. We can conclude that about 62.5% of these 16 users are born in 1980s, and the movie Tokiboki was still quite popular at this time, 10 years after its releasing year. So even though this is a quite small part of our recommendation data, it can still verify the utility of our recommendation system in some extent. That's all. Thank you very much.